Hi everyone. So in today's video, we're going to finish off talking about solving trig equations. So this is going to be the last video about solving trigonometric equations. So the types of equations that we're going to be looking at today are going to be equations where instead of the input of sine or cosine just being x, it's going to be something like 2x or 3x or 4x. And we'll see how that kind of, in some ways, the approach is going to be very, very similar, but there's going to be some key differences at the end as we finish off solving these. So an example of an equation like this would be to solve something like this. So 2 times sine of 2x plus 1 is equal to 0. And so for these problems, I want to do kind of two different approaches to answering them. So the first thing we're going to do is we're going to focus on describing all solutions. So that would be how, like in the past, we would say, our answers and then say plus 2 pi k, although we'll see in this case, it actually comes out a little bit different. So first, we're going to describe all solutions. And then once we have all solutions written down, then we'll also write down a list of 4 specific solutions. So that will come a little later. Okay, so the first step in solving an equation like this is basically just like every other trig equation we've dealt with. So for now, kind of ignore the fact that this is a 2x and just kind of treat this as sine of something, right? And so what's the general first step we take? Well, we always want to start by isolating the sine. So we want to start by isolating sine. So that would look like 2 times sine of 2x is equal to -1. And then that would tell us that sine of 2x is equal to -1/2. So next we're going to do something that is actually kind of similar to something we did in yesterday's video. So what I want to do is I want to think of 2x as being like, don't think of it as 2 times x, think of it as like one item. And so what I'm going to do is I'm going to replace where it says 2x, I'm going to replace that with another letter. So you could use whatever letter you want. I'm going to use U again, because like I said, that's a very common letter to use if you're doing any kind of like substituting something for something else. So all I'm really doing here is I'm just replacing, just to kind of make this maybe a little bit simpler to look at. Instead of writing a 2x inside the parentheses, I'm just going to write the letter u. So sine of u is equal to -1/2. So let's forget about the 2x part and just solve this as we normally would, but now we're solving it for u. So sine of u is equal to -1/2. So that's going to happen when we have angles where the y-coordinate is -1/2. So some angles where that would happen, one of them would be over here. So 7 pi over 6 would be one possible answer. So this would be the angle where the x-coordinate is -√3/2 and the y-coordinate is -1/2. And then another possible angle would be, for some reason I can't draw these well today, would be something over here. Those should be level with each other, but that's okay. So this would be the angle 11 pi over 6. And you could also measure this as a negative angle. So especially when you're trying to give all solutions, it doesn't really matter as long as the two initial angles you come up with are not coterminal with each other. You can give them whatever name you want. So if you wanted to, you could call this angle -pi over 6 instead. I tend to prefer to just work with the positive versions of the angles. Okay, so what did we figure out here? We figured out that u could be equal to 7 pi over 6, or u could be equal to 11 pi over 6. Those are the two answers that we came up with. But now we have to go back to the fact that we're not trying to solve for u, we're trying to solve for x. And so instead of writing u is equal to these things, let's write 2x is equal to each of these things. So 2x is equal to 7 pi over 6, and 2x is equal to 11 pi over 6. So if you wanted to, if you don't like this whole writing the u down stuff, you could skip this whole like middle part. You could skip this, right? You could jump basically straight from the fact that, okay, sine of 2x is negative 1/2. Really the whole point of writing down this u business is to really kind of encourage you to think of 2x as like one item. Think of that as an angle. Don't think of it as 2 times an angle, just think of it as itself an angle. So if you wanted to, you could jump straight from saying, okay, sine of this angle which is 2x, is equal to negative 1/2. You could jump straight to saying, okay, that means that this angle, which is 2x, is either 7 pi over 6 or 11 pi over 6. So try it both ways, maybe see what works better for you. Either way is totally fine. But we're not quite done, right? Because we're still trying to solve this for x. So how do you solve this equation for x? Well, we need to divide both sides by 2, right? Because we're trying to isolate x. So we're going to get x is equal to 7 pi over 6 over 2. And another way of writing that would be 7 pi over 12. So that's one answer that we found. And then similarly on the other part, and actually let me not box this just yet because there's going to be another step at the end. Similarly over here, we would get x is equal to 11 pi over 6 over 2, which is going to be equal to 11 pi over 12 instead of over 6. So those are 2 answers. They're not all answers, but those are 2 answers that work. And maybe just to really convince you that what we did makes sense here, let's actually double check that this works. So let's go back to when we were here. So it's supposed to be true that sine of 2 times x is equal to negative 1/2. So let's check our answers. So if we do sine of 2 times x, so we're doing 2 times the angle we found, we would get sine of not 7 pi over 12, but 2 times 7 pi over 12. Right? So that's what, that's what it means when we're saying we're solving for x. If we were to plug it back into the equation, the original equation was 2 times x. And so when we plug in our angle, we're doing 2 times that angle. And what is 2 times 7 pi over 12? Well, that's going to be sine of 14 pi over 12, which is the same thing as sine of 7 pi over 6. And what is sine of 7 pi over 6? Well, that's the angle that we already found earlier on the unit circle, and we know that sine of 7 pi over 6 is negative 1/2. And that's exactly the answer that we were supposed to be getting, right? We're trying to solve sine of 2x is equal to negative 1/2. So, and same thing if you tried to plug in 11 pi over 12. So I just want to really convince you that, or I guess I just want you to understand kind of how the original equation relates to this equation here. And really what is the relationship? It's that whatever you find as your final answer, if you do 2 times that answer and plug that into sine, that's when you're going to get negative 1/2. It's not the case that sine of 7 pi over 12 itself is equal to negative 1/2, but it is true that sine of 2 times 7 pi over 12 is equal to negative 1/2. So if we're trying to understand whether our answer works, that's what you need to do. You need to do 2 times that number because that was our original equation. Okay, so we're not quite done because we're trying to describe all solutions. So I want to look at a graph for a second and kind of think about like how do we get this plus 2 pi k business that we're always doing? So right now I'm going to pull up the graph of just, this is just the graph of sine of x. So we're not looking at sine of 2x just yet. It's just sine of x. So if we had been solving sine of x is equal to negative 1/2, we would find the solutions 7 pi over 6 and 11 pi over 6. And then if we wanted to describe all solutions, we would say plus 2 pi k. So what does that plus 2 pi k really mean? It basically means that you can add 2 pi to either of these answers as many times as you want, and you'll always get another angle that also works. And so, for example, if you take 7 pi over 6, so that's this one here, and add 2 pi to it. Sorry, I'm just going to try to make sure we fit this all on the screen. So here's 7 pi over 6. If you add 2 pi to that, you get 19 pi over 6. And so notice if you kind of follow the shape of the graph, it goes through one full cycle between those two solutions. And so every time you're adding 2 pi to a solution, you're adding it because that's the period of sine of x or cosine of x. And if you add one period, that's going to get you back to the exact same point. So you can add as many multiples of that period as you want. So what's the difference with the equation we're working with now? Well, our equation is not sine of x, it's sine of 2x. So we're really focusing on solving sine of 2x is equal to negative 1/2. So the period of sine of 2x is not 2 pi anymore, right? It's pi. And I'll write that down in a second, but I want to show you on the graph what we're kind of thinking of. So now I'm going to get rid of the graph of sine of 2x, or sorry, sine of x, that's the one in red, and instead, in green, now we have the graph of sine of 2x. So if you remember how graphing trig functions worked, if you take something that has an input of x and then you change it to 2x, it compresses it horizontally, right, by 2. And so if you look at the graph of sine of 2x, its period is now just pi. It goes through a full cycle from 0 to pi, and then again from pi to 2 pi, and again from 2 pi to 3 pi. So the period of this function is pi. And so what that tells us is, so here's our first solution, right? 7 pi over 12. That's one of the solutions that we did in fact find when we were solving sine of 2x is equal to negative 1/2. So how would we get another solution? Well, if we wanted to go through a full period, it's not going to actually be 2 pi, it's going to be pi. And then similarly here, if we take a solution that was our second solution, 11 pi over 12, and we add now just pi to that, that will give us another solution. So instead of adding any multiple of 2 pi, we can now add any multiple of pi because that's the period of this function. And so when we go to describe all solutions, we're going to end up saying x is equal to 7 pi over 12, and now we're going to say plus pi k, and x is equal to 11 pi over 12 plus pi k. So where does this pi k come from again? It's because the period of sine of 2x, because that's what we're really focusing on here, is pi and not 2 pi. And so in general, anytime we're solving these types of equations where the input is not just x, if we're going to describe all solutions, we can't just say plus 2 pi k. We have to figure out what's the period of this actual function I'm working with and add that instead. So I just want to quickly kind of summarize that. And this is basically just a review from what we talked about before. But as a reminder, if you have f of x is equal to sine of, let's say, b times x, or g of x is equal to cosine of b times x, those two functions have a period of 2 pi divided by whatever that number b is. So for example, we just did 2x and that had a period of 2 pi over 2, which is pi. If your period, or sorry, if b was the number 3, then the period would be 2 pi over 3. And so whatever that result is, whatever you get for your period, that's what you're going to tag on at the end when you're describing all solutions. So let me just write that down. When describing all solutions to a trig equation involving sine of bx, and maybe let me throw in some color here, or cosine of bx, you basically need to add 2 pi over b, as we said up here, times k to each non-coterminal solution. And it doesn't quite make sense to talk about coterminal, not coterminal, but I guess when I say each non-coterminal solution here, I just mean the first solutions that you find, right? Like when we were doing our problem that we just did, we found 2 solutions and then we added plus pi k to each of them. So I basically, when I say non-coterminal here, I just mean the first 2 solutions or the first solution that you find. And let me just make this colorful, so if you have your notes, it looks a little nicer. Okay. So I want to quickly just show you one thing on the online homework, just that is kind of related to this, and then we'll get back to the question we were working on. There's kind of one more thing I want to talk about with that, and then we'll do another couple examples. So I just want to quickly show you that on the online homework, the formatting is a little funny with how it asks for things. So for example, this one you're solving, cosine of 2 theta is equal to negative square root of 3 over 2. So you would do that basically just like we did the example that we just did together. And then at the end, you're asked to write your 2 solutions, and then notice it says plus c times k. And then there's an extra box where it says where c is equal to. And so that's where you put whatever the period is. So for example, in the one that we just did, because actually in this one too, right? So this is cosine of 2 theta. So that means that the period's going to be pi. So in this case, you would type in c is equal to pi because you're supposed to add on pi times k. In this next example, now you have sine of 4t. So the period is going to be 2 pi over 4, which is pi over 2. And so for this one, you would be adding pi over 2 times k because that's the period. And so you would type in c is equal to pi over 2. So I just wanted to point that out because the formatting is a little different from stuff that we've been doing. Okay, so one more thing I want to talk about with this specific example. So like I said, here what we just did is we described all solutions. I also want to be able to write down some specific solutions. And there's one homework question that asks you to do this, and that's why I'm deciding to go over it. So let's now describe the first, or find the first, or I'll say it this way, the smallest, sorry, I keep miswording this, the 4 smallest positive solutions. So what are the first 2 smallest positive solutions? Well, we already found them. That would be 7 pi over 12 and 11 pi over 12. So those are 2 of the first 2 solutions that we get. So we have x is equal to 7 pi over 12. We have x is equal to 11 pi over 12. And then how do we find 2 more positive solutions? Well, we know that if you add pi to any solution that you get, you're going to get another solution. So we can come up with another solution by saying x is equal to 7 pi over 12 plus pi. So what would that give us? Well, if we make a common denominator here, we would get 7 pi over 12 plus 12 pi over 12. And so altogether, that would give us 19 pi over 12. And then for the second one, if we also add pi to that, that will give us another positive solution. So in this case, we would get 11 pi over 12 plus 12 pi over 12. So that would give us 23 pi over 12. So those are our 4 smallest solutions. Smallest positive solutions would be this 7 pi over 12, 19 pi over 12, 11 pi over 12, and 23 pi over 12. And actually, we saw those already on the graph, right? Those were like the first four that we had, the ones that are highlighted right here. So there's one question again where it asks you to do that, and basically you just take your first, your two answers that you came up with, and then you just add the period to each of them, and that will give you your four smallest positive solutions. Okay, so I just want to do a couple more examples, and one of them will be fairly similar to what we just did, and the other one will bring up one other interesting thing that could happen. So for this one, and let's just focus on finding all solutions for these two. So we're going to find all solutions to, so the first one we're going to do is square root of 3 minus 2 times cosine of 3x is equal to 0. So just like we did on the other ones, we want to start by isolating the cosine part. So if we subtract square root of 3 from both sides, we get negative 2 times cosine of 3x is equal to negative square root of 3. And so that tells us that cosine of 3x is equal to, if we divide both sides by negative 2, we end up with positive square root of 3 over 2. So again, we want to kind of think of this 3x as being itself a whole angle. So we're now taking cosine of that angle. And cosine of that angle should be equal to square root of 3 over 2. So we're looking specifically for angles now where the x-coordinate is square root of 3 over 2. So where the first two angles we can find where that happens, well, one of them would be pi over 6. So that has an x-coordinate of square root of 3 over 2, y-coordinate of 1/2. So that's one possibility, is that u is equal to pi over 6. And then another possibility would be the angle 5 pi over 6. Actually, sorry, that's wrong. Because I forgot what we were doing for a second. We're trying to find cosine equal to square root of 3 over 2, right? So that would actually be an angle over here, because we want to still have an x-coordinate of positive square root of 3 over 2. My bad. So that would be, if we measured it this way, that would be 11 pi over 6. So two solutions are pi over 6 and 11 pi over 6. But now we want to remember that that's not really what we're trying to solve for. We're not solving for u, we're solving for x. So we need to, instead of writing u is equal to these things, well, u is the same as 3x, right? That's what we're actually trying to figure out, is when is 3x going to be equal to each of these angles? So now we want to solve this for x, right? And so how do we solve these equations for x? We just divide both sides by 3 in this case. So for the first one, we get pi over 6 over 3. So that's the same thing as pi over 6 times 1/3. And so that's going to give us pi over 18. And then for the second one, if we divide both sides by 3, we're going to get 11 pi over 18. So those are our first two equations, our first two solutions. And so now we want to be able to describe all solutions. So we need to think about what is the period of the function that we're working with in order to be able to figure out what we need to add in order to describe all solutions. So our original equation was cosine of 3x is equal to square root of 3 over 2. And so that means that the period is going to be 2 pi over 3. So the period of cosine of 3x is 2 pi over 3. And so that means that in order to describe all solutions, we need to take each of our answers here, so pi over 18, and 11 pi over 18. And to each of these, we're going to add 2 pi over 3 times k. And that would be our final answer. All right, so one last example I want to do, and this one we're going to see that there's actually kind of two different ways to do it, and I just want to show you both of them. So let's say that we are trying to solve the equation, find all solutions to sine of 2x is equal to 0. So the first method we're going to use is we're just going to solve this exactly the way that we solved the previous ones, the last two examples we did. So if we have sine of 2x is equal to 0, that tells us that, well, okay, we're trying to solve sine of something, right? Some angle is equal to 0. And so where is sine of an angle equal to 0? Well, that's going to happen when we have a y-coordinate of 0. So one angle that would work would be an angle of 0. And another angle that would work would be an angle of pi, right? Those are both angles where sine of that angle is 0. And so we have two solutions here. One is 0. And the other solution is pi. But like we did on these last questions, we want to then rephrase this and say, okay, well, we're not really looking for u, we're looking for x. So we want to rewrite this as 2x, and then see what that gives us for each of these. So for the first one, it's still going to be 0, right? Because 0 divided by 2 is still 0. But for the second solution, we're now going to get pi over 2. And then to write down our final answer, well, we need to add on the period. And so because our original function was sine of 2x, the answer is going to be, or the period is going to be pi over 2, right? So sine of 2x has a period, or sorry, I said pi over 2, but I meant to say pi, right? Because I keep misspeaking. 2 pi divided by 2 gives you pi. And so that tells us that our final answers are going to be x is equal to 0 plus pi k, which we could actually just write as pi times k, right? We don't need the 0 plus pi times k. So basically any multiple of pi is what that part is saying. And then our other solution is x is equal to pi over 2 plus pi k. So that's one way, and that's a totally legitimate way to solve this equation. But I just want to show you one other way that you could approach this. So because our equation is just sine of 2x is equal to 0, we could rewrite sine of 2x using the double angle formula. And I just want to show you that even though the approach is going to be a little bit different, the final answer ends up being the same. So if we have sine of 2x is equal to 0, we know that another way of writing sine of 2x is 2 times sine of x times cosine of x. So we can divide both sides of this by 2, right? Because if you divide 0 by 2, it's still 0. So we end up with sine of x times cosine of x is equal to 0. And so now this is similar to equations that we were working with in yesterday's video, right, when we were solving by factoring. So if we have two things multiplied together equaling 0, that tells us that one of them is 0. So we either have sine of x is 0, or we have cosine of x is 0. So let me just grab a unit circle here because I don't think I had another one. Okay, so let's start with sine of x is equal to 0. So forget about the 2x. In this case, we're we basically took our equation and we translated it into being just in terms of x. So for this one, we never have to go back to the 2x stuff. And I just want to actually really point that out because there's really a difference here. So in this one, we replaced 2x with u. And so u was a completely different variable. It represented something different. U represented 2x. In this one, we used an identity that says that if you have sine of 2x, that's the same thing as 2 times sine of x times cosine of x. So in this case, we don't need to do anything else where it's still the same variable. It's still solving for x is still solving for x. Okay, so if we're solving sine of x is equal to 0, well, we already kind of did that one earlier. So one possibility is going to be x is equal to 0. Another possibility is going to be x is equal to pi. And then if we're solving cosine of x is equal to 0, well, one place where that's going to happen is going to be at pi over 2. So that's one solution. And then another solution is going to be at, I'm trying to choose a color I haven't used yet. Another solution would be at 3 pi over 2, right? That's another place where cosine is equal to 0. So if you look at these solutions, it might seem like, wait, in this example, we only had 2 solutions. In this one, we have 4 different ones. But actually, the 4 answers that we found here can all be described by what's written up here. So 0 plus pi k means that you can have any multiple of pi. So you can have 0, pi, 2 pi, 3 pi, 4 pi, 5 pi. And so that already includes these 2 solutions here, right? These 2 solutions here are described by x is equal to 0 plus pi k, right? Which is just the same thing as saying pi k. And then what about these other 2 solutions? Well, if you take pi over 2 and add pi to it, you get 3 pi over 2. And if you take 3 pi over 2 and add pi to it, you get an angle that's coterminal with pi over 2. And if you add pi to that, then you get an angle that's coterminal with 3 pi over 2, and so on. And so what that means is that these 2 solutions here, these can both be described by x is equal to pi over 2 plus pi k. So we end up, either way we do it, we got the exact same solutions that we had up there. And I'm partially pointing this out because there's a homework question where you actually have to use the double angle formula. And I just want to quickly highlight that for you. So that was, I think, number 6. So in this case, you don't want to do this question the way that we were doing the earlier questions in the video. And the reason for that is that this blends together 2x and x. So because of that, you really want to start by using the double angle formula that we just used, because then everything's in terms of x and you'll be able to solve it by factoring. So I just wanted to quickly point that out. All right, so that is it for today. Like I said, we will actually be moving on to some totally new, different stuff that is not trigonometry tomorrow. So yeah, hopefully the trigonometry part wasn't too painful. But yeah, I think there will be some pretty cool stuff coming up in the remainder of the class. So yeah, enjoy, and I will see you next time.